Here we look at a buffer calculation where I've been asked to work out the mass of sodium benzene carboxylate that should be dissolved in a decimeter cubed of 0.012 mole per decimeter solution of benzene carboxylic acid to produce a buffer with a pH of 4.0. And we've also been given the acid dissociation constant. First thing we would say is that benzene carboxylic acid is in effect my HA, my weak acid, and my sodium benzene carboxylate is my A minus, my salt of my weak acid. So what we want to do is calculate the mass of the A minus, the mass of the salt of the weak acid that should be dissolved. Now, the first thing we do is we're going to write down the expression for Ka. And we should be aware that this is what it is. Now, what we need to do is we need to work out the mass of, in effect, the A minus. We need to work out the mass of this. That's my sodium benzene carboxylate. So what I'm going to do is I need to rearrange that equation in order to produce A minus. So if I rearrange this equation, then A minus then is equal to Ka times HA over H plus. Now, if I look at my question, I've been given my Ka value is here. So I've been given Ka. My HA is given here. That's the concentration of my benzene carboxylic acid. My hydrogen ion concentration can be deduced from the pH. So the pH here is going to give me my hydrogen ion concentration, and this here is my HA concentration, and there I've got my Ka. So I've got everything I need in the question in order to work out this A minus concentration. So then A minus then will equal my Ka, which is 6.31 times 10 to the minus 5, multiplied by HA, which is 0.0120, divided by my hydrogen ion concentration, which is 10 to the minus, with the pH, which let's just have a look, yep, is 4.00. When I do that calculation, I should get 7.57 times 10 to the minus 3 moles per decimeter. So that's the concentration of hydrogen ions, of A minus ions that I require. In order to work out the mass, I need the moles. So how many moles are there going to be? Now, it tells me I've got 1 mole per decimeter. This is in 1 mole. This is the number of moles in a decimeter. So I've also got my moles of A minus will equal 7.57 times 10 to the minus 3. Okay, so that's my concentration. So if we really want to work this out, if I want to work out moles, it's conc times vol. I've got my concentration here. My volume is simply 1. So that's why my moles is the same as the concentration. So if I want to now work out mass is Mr. Moles. So my mass then is equal to the MR, which is given in the question as you can see here, 144.0. So my MR is 144.0 times my moles, 7.57 times 10 to the minus 3. And that will give me a mass then of 1.09 grams. And that there is my answer.